Welcome back. Today we're going to be starting a new module, and we're going to be talking about sequences called arithmetic sequences. Okay, so arithmetic sequences are sequences that have what we say is a common difference between each term, meaning that to get from one number to the next number in the sequence, we either have to add or subtract. So an example of this would be the sequence 7, 9, 11, 13, 15. So these are like the odd numbers starting with 7. Sequences that require you to either add or subtract between the numbers in the term are called arithmetic sequences. Okay? Ones that need to be multiplied or divided to go from one term to the next term are going to be called geometric sequences, and we're going to study those a little bit later in another module. Now, we've talked about different ways of writing sequences before. There's either the explicit way or the recursive way. So explicitly is writing the formula using some operation on the first term. And for us, for the arithmetic sequence, we're going to use what we call the common difference. All right. Now, let's just look at the explicit formula here. So to get any term in the sequence, you take the first term. So a sub 1 is the first term, if you recall. And you add to it the term number. So if n is the term number, you add to it the term number minus 1, and you multiply that by d, the common difference. All right, and we're going to do some examples pretty soon. So I just wanted to walk you through what this was, what this formula was. Now, if you recall, writing sequences recursively means writing them so that what you're doing is you're doing operation to get to the next term, you have to operate on the previous term. Okay? So again, explicit means starting with the first term, you do something with the first term in order to get to the term that you want to get to. So this allows you to skip terms. Writing it recursively, you can only go one term at a time because every term is defined by the previous term. So this is saying take the previous term and add the common difference to it. So recursive formulas end up being easier formulas to deal with, so you can see that here, right? Except that you can't skip terms in recursive formulas. All right, so let's go ahead and try something else. So let's take the sequence that we were looking at before, which is the odd number starting at 7, and let's write explicit and recursive formulas for it. So the explicit formula, what we do is we take a sub n, and let's recall back, we start with the first term, a1, and we add to it, so a sub 1, I can actually, here, let me write the general, this is the general formula, a sub n is equal to a sub 1 plus n minus 1 times d. Okay, let's write that. So that's the general form of the explicit formula for an arithmetic sequence. So for us, let's fill this in. We're going to keep a sub n as a variable. So for any term that we want, for instance, we take the first term. This right here is the first term, 7 plus. Now, we're going to leave n minus 1 in as a variable. Now the common difference here is going to be plus 2. So what this is doing is it's adding 2 between every term. So our d in this situation is equal to 2. All right. So let's look at this formula. This is saying for any term that you want, and this actually should be an equal to sign. For any term that you want, an, you want to take 7 and you want to add to it 2's. But you want to multiply 2 by however many terms came before n. So we're going to do an example here. Actually, let's find f of 15 right now. So f of 15 would be, I'm looking for, actually not f of 15, let's look at a sub 15. That's going to be equal to 7 plus, and so if the term number is 15, I'm going to do 15 minus 1 times 2. That's equal to 7 plus 14 times 2, or 7 plus 28, which is equal to 35. So a sub 15 is equal to 35. Because look at what happened. You took the first term, and so between the first term and the 15th term, how many 2's? Because every time you add a 2, to go between one term number and the next term number, you're adding 2. So what you did is you added 2's 14 times. To 7, you added 2 to 7 14 times. That's why you have 2 times 14, right? That's what this formula is saying, okay? So it's always to get the term amount, you take the common difference, multiply it by the term minus 1, and add it to the first term of the sequence. All right, that is the explicit formula. Now the recursive formula just says take a of n is equal to a of n sub 1 plus the common difference, which is 2, right? So that makes sense. So it's easy for us to do this. Actually, in order to find a sub 15, I would have to figure out what a sub 14 was, right? So here to get a sub 15, I'd have to find a sub 14, then a sub 13, then a sub 12, a sub 11, and so on. So I'm not going to try to find a sub 15 using the recursive because it would take me a while to do that. And since I already have a sub 15 using the explicit formula, we're all set here. But this is how you can write it in terms of the explicit and the recursive formula, because that's what you're going to need to know. Now notice that the things that we kept as variables, right, are when I'm trying to find a term number, I keep this as a variable because I don't know what it is. The things that I plugged in for this specific problem is the common difference, okay? In the explicit formula, the things I plugged in were 2 and 7, all right? What I kept in as variables were n minus 1, that's always there, and a of n, a sub n, okay? So the things in green are what you plug in for the formulas that you're answering the question for, whereas everything else in yellow you keep in the formulas as variables. Okay, let's try it one more time. So here, what we need to do is we need to figure out what's being added. So between 3 and negative 6, it actually drops down. So 6 plus what equals negative 3? Well, it'd have to be something negative because it decreased, right? So 6 minus 6 is 0. And then it gets another negative 3. I'd have to actually add negative 9 to it. So negative 9 is the common difference. Negative 3 plus negative 9 is negative 12. So it's always the D in this situation is negative 9. So the explicit formula is a sub n is equal to, I start with the first term 6 plus n minus 1 times 9. Okay. Another way you could write this is an is equal to 6 plus 9 times n minus 1. You might want to put the 9 as a coefficient to the n minus 1. Either way, it's fine. Okay, so that's the explicit formula. The recursive formula says a sub n is equal to a sub n minus 1 plus the common difference, which is negative 9. If I wanted to simplify that, I'd have a sub n is equal to, a sub n, right, is equal to a sub n minus 1 minus 9. Okay? Yep, that's the recursive because I take the previous and I subtract 9 from it. Now to find f of 10, or this is going to be the same as asking a sub 10, I'm going to use the explicit formula because it's a lot easier. What I do is I take 6 plus, now let's say 9 times 10 minus 1, which is 9. So this ends up being 6 plus 81, which is equal to 89. Okay, so a sub 10 is equal to 89. And that is the end of the lesson for today.